So a jogger runs eastward. Okay, so this problem's using north, south, east, and west. So we'll put that up here. So we're using north, south, west, east. So a jogger runs eastward in a straight line with an average velocity of 2 meters per second for 2 meter per second for 5 minutes. Are those going to work or not work? Not work. So we got to convert the minutes into seconds. We'll have to convert minutes into seconds. And then continues eastward with an average velocity of 1.5 meter per second for 2 minutes. Okay, so set up a little diagram. Diagrams are your ticket to getting it. Set up a diagram. So we got the jogger. So the first thing this jogger does, moves in region 1. So we'll go do. This is kind of like the first part of the, and then the second part. Now, let's see what happens here. So the first part of this jog, the person has a velocity of 2 meter per second for a time. So 5 minutes is how many seconds?
300 seconds.
300 seconds. Okay, the second part of the jog, the person has a velocity of 1.5 meter per second for a time of 2 minutes, which is 120 seconds. Hey, does this person change direction? Nope. The person goes east and then east some more. Okay, so no change of direction. What is her total displacement? So we got to figure out the delta x for the first part and the delta x for the second part. So what's the equation that we're going to use here? Velocity is displacement over time. So what's displacement going to be equal to? Velocity multiplied by time. Right? Just rearrange the equation. So how do we get this delta x? We're going to go v times the time. So that's going to give us 2 meter per second for 300 seconds. So what is that? 600 meters. Okay, same thing for this one. V times t. So now it's going to be 1.5 meter per second for 120 seconds, which is going to be 180 meters.
What does that say next? 2 meters per second, 300 what?
Oh, 2 meter per second.
Oh.
So this one here, the seconds cancel, and you get 180 meters. So what was the total displacement? The total displacement, you add these together,
780 meters.
780 meters. This is east. Oh, thank you. 780 meters east, because displacement's a vector and it needs a direction. Okay, B, what is her average velocity during the whole trip? The average velocity for the whole trip. Can you just take these, this velocity and this velocity, add them together and divide by 2?
No.
No, you cannot do that, because why? Which velocity is lasting for a longer period? The first one, which is why you can't. If they lasted for the same period of time, then you could add the 2 together and divide by 2. So how do we go about finding the average velocity for the whole trip? Well, what's the definition for velocity?
Total distance over total time.
Yeah, you take your displacement, divide by the time. So what's her total displacement?
Alright, it's 111.4 meters per minute.
Well, what's her total displacement? We already figured it out.
Total is 780 meters.
Uh-huh. And what's the total time?
7 minutes.
420 seconds. Okay. Right, you add these 2 times together. 300 plus 120. So 780 divided by 420, 1.86 meter per second. That's the answer to part B. Okay, C. If she then returns to the point where she started, what would be her displacement? So look, yeah. So she starts over here. She goes all the way out here and then comes back again. What is her change of position? 0. The displacement is 0. What would be her average velocity? 0, because velocity uses displacement. You know, delta x over delta t. Her displacement is 0, so her velocity would be 0. What would not be 0? Her distance and her speed. Her distance and her speed would not be 0, but we can't figure that out because we don't know the time for the return trip.